all of today, let's go. All of today, the entire day today, I'm going to be teaching you different ways to prove, you're not literally going to be writing proof, but I'm going to be showing you things that will help you know if triangles are congruent to each other. All day today, we're going to have two triangles, and I'm going to be showing you different ways to prove that those two triangles are absolutely congruent with one another, which means they equal. You cannot just assume that. If I were to show you two triangles and say prove they're congruent, as of right now, unless it told you that every side was the same and every angle was the same, which isn't that the definition of congruent, they all have to be the same, unless I were to tell you every bit of that stuff, you could not assume the triangles were congruent. But today, I'm going to be showing you 1, 2, 3, 4, 5 different things that will allow you to just conclude that triangles are congruent. The first, and you definitely need to put all these in your theorems and postulates. You're going to need every one of them on proofs. The first one is side, side, side. Side, side, side. Now, again, let me reiterate while you're writing these down. And you're definitely, even if you don't write down the notes, you probably at least want to write down SSS or something. All of these theorems and postulates, without them, you would have to literally know every angle and every side are the same to show the triangles are congruent. But with these theorems and postulates, you don't have to know all those things. This postulate says, the sides be darned. If two triangles share 3 common sides, that's enough. That's enough to know that these triangles are congruent. So they're saying you don't actually have to know the angles. If the sides are all congruent, that's enough. So, how will you be using this? Today and tomorrow, I'm going to be showing you 2 triangles. If on any of them you do not know any angles, then this will have to be the one you're going to have to hope to use. This is the only one I'm going to give you today that doesn't require any angle measurement. But you have to be able to conclude that all 3 sides have a corresponding congruent part in the triangle. If 2 of them do, that's not enough to use the postulate. It has to be all 3. Now the beauty of this postulate, if there's no angles, you won't ever have to worry about alternate interior or vertical or linear pairs. You're not going to worry about any of that angle stuff to use this postulate. This one will be very straightforward. You'll either have the sides or you won't. Anybody need me to leave this up there? You don't. Just no. No, you do not have to label that every time. I mean, there may be some that you'll see in the examples what you'll be asked to do. All right, side, angle, side. This is the second thing, that if you know those 3 pieces, you can conclude the triangle is congruent. Every one of these things I'm showing you today, you're going to need to know 3 things. The last one was 3 sides. This one is 2 sides and an angle. Now there's a very important thing to notice here, but I'll wait for you to have a moment to write it down before I start. Okay, as you're writing, please notice, both in the acronym SAS and in the picture, the angle is between the sides. Do you see that? Please notice that the angle that we have in these pictures is perfectly between the 2 sides. That is the only angle that we could use to use this theorem postulate on. If I had known angle P or S or V or W, you couldn't use this theorem. And here's the way I always remember that. Here's the way I always remember that. SAS. The A comes between the S's, right? If it didn't, it would spell a profane word. If you can spell a profane word with the 3 pieces, then you can't use it. That's a good way to remember it. If your angle let's say it had been this one. See how it's not between the sides? So you could call that ASS. Then you can't use it. That is not a theorem. Now, we're going to dedicate a whole section for me showing you why you can't use that. It's not definitive. Well, actually, I could just show you right here real quick. Oh, I didn't boot up my board. Oh, thank you. Yeah, but do it in a minute. Okay, look at these triangles. I'm not going to affect any of the pieces that are in red, but couldn't this right here? These are the same length. See that? I haven't changed anything about this triangle except for this angle. But notice there's no loop through that angle. And that's the only thing that I've changed. Because these would still be the same length. The point is, both of these could be formed with the same pieces. Two different triangles. That's why this angle and this side are the only pieces. If the angle is not between the sides, then you are looking at a potential two separate triangles. So all this is to say, if you're going to use side angle side, and it's the only one I'm in, well, that's not true, then the angle has to, 100% must, be between the sides. That is a major point to that postulate, and you may want to make a note of that somewhere. Angle has to be between the sides in order to use that. There is only one time that you can use that it doesn't have to be between the sides, and you can still show the triangles congruent. We'll show that in a second. Before I show you that, you may have already known this, but we're going to go and talk about it anyway. Every triangle that's a right triangle. Now, let me preface this by saying, the last two theorems of postulates did not have to be right triangles. They don't. But the next one I'm going to show you does. A right triangle has two legs and a hypotenuse. The hypotenuse will always be directly opposite the right angle. You see how it's not touching the right angle? That's how you'll know the hypotenuse. It's the one not touching the right angle. That's important if you're going to understand the next theorem. The next theorem is the only time that you can know two sides in an angle, and it doesn't have to be between the sides. And it is, all you really need from that is to know what the legs and hypotenuse are. That's all you really need to know. This one. The hypotenuse leg congruence theorem. Now notice, is my angle between my sides? On that picture, is the angle between the sides? No. It would need to be this angle. And if we had been given this angle, then that would be side, angle, side. But it's not. And this is the only time that you can use two sides in an angle, and it doesn't have to be between. And that is if it's a right angle. The hypotenuse leg congruence theorem states that if you have a right triangle, if you have two right triangles, and you know that the hypotenuses are the same, and at least one of the legs, that's enough to know you have a congruent triangle. Let me ask you this, outside the box question. Why do you think it has to be hypotenuse leg? Why couldn't it be leg, hypotenuse, leg? Why do they specify hypotenuse? What if I knew these two sides? Why is it not necessary for this theorem to talk about this situation? Give you a hint. The very last thing you wrote down covers it. Not the definition, the last postulate you wrote down. Well, what's the last postulate I gave you? Side, angle, side. If we'd been given these pieces, you could just use side, angle, side. And you wouldn't even need this theorem. The only time you need this one is if it's a right triangle and you don't have side, angle, side. So you can use the hypotenuse leg congruence theorem. And while you're writing this down, let me tell you, here's what we're doing. I'm giving you 5 of these today. And then what I'm going to do is I'm going to give you tons of two triangle problems. And you're going to have to tell me which of them you have to use to show the triangles are congruent, if you can at all. That's where we're going. I'm going to give you tons of two triangle scenarios, and you have to tell me which one we're using to figure out their congruent. Anybody need me to leave this up there? This is the only one all day that requires a right angle. Only one. Now the next two are kind of the same thing. I don't even require that you write both of them. But everything we've done so far, you've had 3 sides, no angles, 2 sides and 1 angle. So what do you think comes next? 3 sides, no angles, 2 sides, 1 angle. What do you think is going to come next?
2 angles.
Exactly. 2 angles and 1 side. And that's what? Angle, side, angle. If you know 2 angles and 1 side, then you can use angle, side, angle. Now you can just use this one. The very next one I'm going to give you is angle, angle, side. But that's not necessary. Because the last section that we covered in here, which albeit was like a year ago, it seems like, the last section we covered in here stated, if 2 angles of a triangle are congruent, then the third one has to be. And I remember we did examples out loud, because I said, what if it's 50 and 60? You guys just subtracted, like, well, the other one would have to be 70. If 2 angles of a triangle are congruent, the third one has to be congruent. So that's why, even though the next slide is a completely separate theorem that says angle, angle, side, which means the side wouldn't be between the angles, it's really unnecessary. Because once you know 2 angles, then you actually know all 3 by the third angles theorem, and you could always just use the angle, side, angle. You wouldn't have to use one or the other. That's why I'm not even pointing out so much that the side is between the angles, like I did for side, angle, side. You do not have to write this one down. Oh, sorry. You want me to go back? No, just a second. Did you need me to go back? No, this one you do the next one. Again, because as long as you always just remember, if I have 2 congruent angles, I've actually got 3 by the third angle theorem. But the 2 are the same, the third has to be the same. If you remember that, then you can always just use this one. You won't actually use the third one. Or the other one. If you've got 2 angles, you've actually got 3. Because simple subtraction is proof. Everybody got this one down? So even though I told you I was giving you 5 today, I'm really only giving you 4, but you do need to remember that you will need the third angles theorem, which states if you have 2 angles, you actually have 3. Okay, notice, I'm not going to make you write this one down, because it still requires 2 angles on the side, but with the third angles theorem, it's completely, obsolete. Okay, now we're getting down into the problems. Now you need to start a sheet of paper with your name on it, and you're going to turn that in tomorrow with your assignment. We're going to do all those problems right now together.
I like that thing we did the other day.
Which is?
Well, receiving each other.
No.
We'll probably do stuff like that.
I made my partner.
Who's your partner?
Drew was my partner.
Oh, please.
Well,
I have different variations of that kind of thing. We can mix it up in the future. Okay. So you are asked to determine, do we have enough information to determine that these triangles are congruent? Question, how many angles do I know on number 1? How many angles do I know? Angles. 0. So what is the only thing that I gave you today that we might be able to use on that? Side, side, side. If we are going to be, now that's not technically the answer yet, we have to be able to know, how many sides do I know those 2 triangles have in common? 2. Now, this is something you're going to use a lot in this chapter. Is there a way that I can show that their third side is also congruent? You're right. Well, we don't know it's the right triangle, but I know you're meaning this side, right? But how can I prove that that side is the same for both? It's one of them. They share it. Who remembers what that's called? No, that's somebody's second hand. It was Tupac's cousin. Oh, Tupac's cousin, dang it. Do you remember what TPOC stands for?
Transversal property.
Close. Transitive.
Transitive.
The transitive property of congruence. The transitive property. No. That's my mistake. Not transitive. The reflexive property. My mistake. The reflexive property. My bad. The reflexive. This is the two separate. The reflexive property of congruence states if two triangles, or any shape for that matter, share something in common. If it's the same for both triangles, then that's the same for both. Therefore, you know that this side is congruent for both triangles, and you could say side, side, side. That's what you're going to be asked to do all day today and tomorrow. You have to be able to say, oh, well, I know this is the same by the reflective property, and therefore I know side, side, side. The reflexive property of congruence, comma, side, side, side. As long as you know what they stand for, that's fine. Reflexive property of congruence, comma, side, side, side. What about number 2? Do we know any angles? No. So if we're going to show these congruent, we're going to have to use side, side, side. You're right. You're exactly right. We're going to have to use reflexive property again. We know the 6s are the same. We know the 9s are the same. How can I show that that 4 is the same for both triangles? The reflexive property. Let me give you a hint. Anytime your two triangles are snuggling with each other, anytime your two triangles are like all up in each other's business, you're going to need the reflective property of congruence, I can almost guarantee you. Anytime they share an entire side, you're going to need the reflective property. I can almost guarantee it. So even on a test, if you're like, man, gosh, I don't remember how to do this, but I think he said anytime the triangles are snuggling, I should throw in RPOC, then just throw it in there. I'm never going to con off for too much information. If you were, I don't want to encourage anything, but if you were to write down transitive, reflexive, substitution, you know, if some of that was right, I'd probably give you credit for it. Now that doesn't mean you can write, hey, I know there's congruent, side, 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 side angle, side angle, side angle, and you can't just name all those and expect to get the answer. But as far as like, if you were to throw RPOC randomly into a problem where it didn't apply, I wouldn't count off for it. So when they're touching, just go and throw reflexive in there. Play it safe. Reflexive property of congruence. Reflexive is really the only thing that you can do that with. Throw it in there if they're touching. Are there questions about why those are the answer? No. No. That was not a pun. Okay. 2 more. Same thing. Now, RST. Geez, that looks like 4 different triangles. We have to make sure we know which triangles. RS. Now, you're probably looking at that and thinking, oh, look, these 2 triangles share a common side. Make sure you're looking at the right triangle. RST is that top one, and VPU is the bottom one. This piece here is completely irrelevant. You don't even need it. Make sure you identify what you're looking at. Top triangle, bottom triangle, what can I use? They give you all 3, don't they? Now, there's another thing you could use here. Who can tell me? And if Lena was here, she'd be bursting at the seams trying to tell me. What else can you use to show these 2 triangles? I'm only going to require you to know one. Well, that doesn't show they're congruent, but that's going to help us show. You know that vertical angles are what with each other? So thank you. So you know these are congruent because they're vertical angles. So what else? If you know those angles are congruent, what's something else you could use? God, Jonathan, yes! Side, angle, side. The angle is between 2 sides that you know. So you could have also used vertical angles theorem and side, angle, side. Muy bien. Very good. And that's all you could have used. Now, I'm not going to require this, but there are so many different things they're going to sprinkle in there. What if they had told you these lines were parallel? Now, all of a sudden, Remember, anytime they tell you lines are parallel, that should be a hint for what? You don't even have to use specific things. Just give me a general statement. Anytime they throw in parallel lines, what's that probably going to be a big hint to? Some kind of angle relationship, like alternate interior, corresponding. If they had told us that these are parallel, now we're going to have all kinds of other things we have to look for, which may not have helped us for that particular problem, but just be looking for stuff like that. Number 4, what do I do? Throw in RPOC. They're right next to each other. Now, if this was a proof, you couldn't just say RPOC. You'd have to say, what is RPOC telling us? And here's how you'd write that. You would write RPOC as your reasoning, and that allows you to know that GH is congruent to GH, which seems obvious, but that means it's the same for both. Now, you don't have to write that, but that's what it would be telling you. Boom. Side, side, side. All right. Skiddly-doo, we're marching along. RPOC, side, side, side. Questions? Let's just keep going. Let's see. Looks like we have 3 more slides. No, sorry. Okay, sorry. This one tells us which one to look for. The directions are helping us. It says, do we have enough information to use side, angle, side? Okay. Do we have enough information on this one to use side, angle, side? Somebody raise your hand and tell me. One of these. Oh, you want that hand or is that on the board? You want to take it again? Say it. Yes, we do. Yes, we do. You're correct. Look, side is basically, here's what you need to know. Do you know 2 sides? Yes. Side, side. Do you know an angle? Yes. Most important question. Is the angle between the sides? Yes. So I can use side, angle, side. If it had given us these angles or these, you couldn't use it. Because it has to be between. So this one is yes. Number 2. Usual suspects. I'm calling on somebody different. Hey, Justin. What's up? You think you want to tackle number 2? Now, Justin, notice we don't have any angles technically, but do we have all 3 sides? No, it doesn't tell us the third one, does it? You can't assume that. But you do have 2 sides. Now, hint time. You know you get 2 sides. The third side is not laying on top of itself, so you can't use RPOC. So you probably can't use side, side, side. You're going to have to use something with 2 sides and 1 angle. Yes, sir. That's exactly what you would do. Remember, anytime you see the bow tie shape, vertical angles. Vertical angles theorem. Now, Justin, what would we use? Side, angle, side. Now, technically, by the directions, this was just a yes or no question. Do we have enough? Why, yes, we do. But let's go ahead and just work them all out the same. Vertical angle theorem, side, angle, side. Yes, that one's yes. Number 3. These people, I love it, but I gotta put these people. Darla. Hey, what do we think? Let me ask you this, Darla. Are your 2 triangles colored right there? Sorry. Are they just laying on top of each other? Are they completely adjoined along a common side? Yes, they are. Very good. You know 50-50? Yes, probably right in. Now, when they're sharing a common side, what do you automatically just throw out there? Yes. RPOC. Who can tell me which side does RPOC help us know? No. XY is the same for both. Now, Miss Smothers, what would we use to wrap up this problem? Well, let me ask you this. How many sides do we have per triangle? Well, you have to look at one triangle individually. How many sides do you know on that one? Just that triangle. How many sides have dashes to them? 2. How many angles do you know? 1. What is the only thing that I gave you that doesn't use a right triangle that uses 2 sides and an angle? Is the angle between the sides? Yes, it is. So that's what we're going to use. Yes, sir. Top one. Oh, what an observation. Foolish, Mr. Crawford. We still use our POC. However, this guy was wrong. That was me I was pointing to. I was wrong. Because even the excellent observation, Donovan, we should keep this back. Because this one, the angles between the sides, this one it's not. Ooh, sneaky. So, this one's actually a no. No, we can't. Sure, right, all snap. One of them was yes, the other was no, but they both have to be the same. That one would have tripped me up on a test. Make sure you watch out for that kind of stuff. Questions? All right, 2 more slides. I'm calling on people who haven't said anything yet, so you better be locked in. Number A. Number A. Eeny, meeny, miny, Elon. Elon. Does it tell me any sides in this picture? No. Of all the theorems I showed you today, how many of them use no sides at all? Do you have it in front of you? Maybe you can borrow Alicia. How many of them use no sides whatsoever? None of them. Those 5. But you're right. None of them. If you do not have a single side, you can't prove triangles are congruent. This one's immediately, can you prove it's congruent? No, not enough information. Now some of you are like, ooh, what about vertical angles? Vertical angles would show you these angles were congruent. What else could you use to show those angles were congruent? What else could you use to show that those 2 angles were congruent? Sorry? You can't use that stuff unless you know the lines are parallel, which it doesn't tell you. But, didn't I say earlier, if it gives you 2 angles, then you know the third has to be the same. Because what if this was 30 and that was 40? This would have to be 110, just by simple subtraction. If they ever give you that 2 angles are congruent in both triangles, the third angles theorem allows you to just know the third one is congruent as well. So, you could have been like, hey, vertical angles, or third angles theorem, but all that does is tell you the 3 angles are congruent, which is not enough to show the triangles are congruent. Now you may be thinking, why isn't it enough? Right? If the angles are the same, why isn't it the same triangle? Well, let me ask you this. Let me get out my shape generator doodah. Take a look at that there triangle. Okay? You see it? Would you call that a regular triangle? What are all 3 angles of a regular triangle? 60. Was that a regular triangle? 60. Is that a regular triangle? All of those, all 3 of those triangles have all congruent angles, but are they the same triangle? No, one was huge, one was small. You have to know at least one side to show triangles are congruent. Okay. Part B. So, I'm sorry, A was not enough information. Nope. Part B. Hold on. I've already pulled these on. I have yet to call on Rachel, Jensen, or Elijah. Drew! You thought I was just going to look right over you. Drew! What do I know? That's exactly what you know. Vertical angles. Now, what could I use to show these are congruent? Oh, you didn't write down your theorem, but you're trying to go solely on memory. Who's going to help them out? Jasmine, what can you use now to show these things are congruent? No, that's only if they are like literally laying on top of it. Justin. Angle. Side angle. Very good. Angle, side angle. Now, C. You can't use angle side angle. Why not? Why can't Elijah? Why can't we use angle side angle in part C? Well, think about that acronym. ASA. This is the S between the A's. Wouldn't this have to be the side that's between the angles? But that's not the one we have. And I said, don't worry about angle side. Well, that would have. This is technically an angle side. But how can we do it without using that? Without using angle side, how could we figure out this problem? There is a way. We talked about it 2 problems ago as a hypothetical. On A, we talked about it. This one doesn't have. You could. But I'm saying, how could we do it without using angle side? Yes, ma'am. Thank you. The third angles theorem. That's an important one, y'all. I'm going to pull the dean up in here and say, y'all. If you know 2 angles, then you immediately know the third by the third angles theorem. The third angles theorem said, hey, if you have 2, the third one has to be the same 2, because by subtraction. So if you know 2, you immediately know the third. In fact, that might just be a safe thing for you guys to always just jump into. If you ever see that you have 2 angles that are the same, just immediately start with third angles theorem and call the third one the same. Now, what could we use? No, Rachel. That's right. Angle side angle. Now, if you're sitting there thinking, Mr. Crawford, you're an idiot. Why didn't we just use angle side? Yes, you could have, but that is so much more fun to do. Make more conclusions. Why come up with one answer when 2 is more fun? Okay. Uno más. Who knows what that means? One more. Slide. Not problem. I normally throw in a little bit, sorry. Okay. Now, number 1. Now, some of you in the audience are thinking, ooh, I see a right angle. Make sure you know what you're going to say before you just know what I think you're going to say. Leave your hand shot up there for a second. If this was The Price is Right, you would have to not answer. That's the wrong thing to do. Jeopardy is what I meant. I've already heard you. Oh, Becca! Hey. Number 1. Senorita Craig. Wait, which one is the... What's the difference between Senora and Senorita? Which one is married? Senora or Senorita? That's the married one? No. Senorita Craig! What do I know? Yes, what else do I... Look, I've only got 2 pieces. I've only got 2 pieces. You need 3 to prove a triangle. How can I find a third piece? Is there a bow tie in that picture? Which means vertical. Now, how would I wrap up this problem, Senorita Craig? What? What would I use? Side, side, side. Yes, you do. How many angles do I have? Per triangle, how many angles do I have? 2? Well, technically 3, right? If you know 2, you have the third. How many sides do I have? In your notes, what's the only thing I gave you with 2 sides and 1 angle? That's 2 angles. That's 2 sides, 1 angle. 2 angles, 1 side. That's right. Vertical angles theorem, and I'm just going to assume you were going to finish that. ASA. Now, some of you, see, but do you know the hypotenuse? Ah, that's where I would have looked. See, that's why I said, I know some of you are chomping at the bit to say hypotenuse leg. You speak, ooh, right triangle. He told us the right triangle ones were going to be hypotenuse leg. But you don't actually know the hypotenuse. So, before you jump off the bridge, make sure you know how deep the water is. Okay. I'm not saying you should jump off a bridge. That's not what I'm saying. Not what I'm saying. Number 2. Now, I told you 2 problems ago when it was me and Jez. No, I think it was somebody at that back table I was talking to. I said, as soon as you see 2 angles, what should you immediately... Oh, it was Rachel I was talking to. What should you immediately just start with if you have 2 angles? Okay. Third angles theorem. If you have two, go ahead and mark the third with the third angle theorem. Anytime you have three angles or two and a side, what can you use? What? No. Am I linty? Are you linty? I have tape. But not yet. Dude. We had some momentum going. That never happened. What can we use now? Cameron, I don't think I've called on you yet. Mr. Humphreys, what can I use to finish this up now? Now that we know all three angles are the same, thanks to someone telling me the third angles theorem, thank you, Caitlin, what can we wrap it up with, Cameron? Now, here's the thing about these. You don't really need your theorems. Just say to yourself what you have. How many sides do you have? I mean, per triangle. You only know one side per triangle, right? Okay. What's the only one I gave you today with only one side in it? With only one S in it. No, we didn't even do that one. Dude! Cameron. Said it. Did you hear him? Which is? There you go. Anytime you have multiple angles in one side, you will be able to use angle side angle as long as you just kind of routinely throw third angle theorem in. If you throw that in there every time you have two angles, then it doesn't really matter which angles you use. You'll be able to use third angle side angle. Last one. Who's going to end us up with a bang?
I know.
What? Mr. Freeman. Mr. Freeman. I'm like really waiting for serious. Now those look like right triangles, but you can't assume they are. So what do I use? Can I use? Oh, you think you've got it? I'll be coming right back to you, Trip. What do you think it is? That's incorrect. Why is that incorrect? Because you could spell a bad word if you were to make it backwards. Anything you can do to that, you can't. You can spell a bad word and you can't use it. There is no angle side side. So back to Trip. Ooh, it is if you flip it. Well, okay. Well, in the Bible it talks about a donkey. Well, you can't take it. That's on you. Can we please focus? Ooh, gravy. Just takes that little bitty bit. Oh, spices. Finish the problem. You're right, you can't. Why can't you? It's impossible. This one. You can't do this one. You can't do this one because we don't have an angle side side pole theorem. We don't have one of those. Now, things that could have helped us with this problem. Things that could have helped us. If it had told us this angle instead, what could we have used? I didn't say it was a right triangle. If it had just given us this angle in general, what would we have used? Talk. Just talk. That's my job. Okay. If it didn't give us this angle and gave us this one instead, it was going to be side angle side. If it had been a right angle, why couldn't we? Somebody tell me. If it had been a right angle, why could we still not have used hypotenuse leg? If we don't know the hypotenuse. To use hypotenuse leg, and I know we didn't use it today, but you are actually, we're going to do one more. Literally one more. You've been working as Mr. Crawford. We're exhausted. We're almost bloody finished. You know, we'll get to the Goonies as soon as this problem's over. I'm not starting it till we're done, so you might as well focus.
You failed.
How do you do that?
Oh my God.
People, why are you being so mean to me? Okay.
Every time that you possibly
Yeah. You're making me angry. Okay, now, this is the last one if we get it right. Miss Brown, what do we automatically start with anytime two triangles are all up in each other's business? Miss Brown! That's right. We use ARPOC. The reflexive property would allow me to say that these two sides are congruent. Now, Mr. Humphrey, since you're hiding, if we know that that middle piece is the same, how would we finish this one up? No, I'm just really anxious for a right answer. If you need to phone a friend, you may phone Drew.
Maybe they're not friends.
Not the point. Let me ask you this. I know, isn't it painful? Let me ask you this, Cameron. Are those right triangles? Do we know the hypotenuse in those triangles? Which is the side opposite the right angle? Yes, we do. So what are we going to use?
Please.
Blake, what are we using? Hypotenuse leg congruence theorem states if you have two right triangles and you know two sides with one of them being the hypotenuse, you can use the hypotenuse leg congruence theorem. Yes, ma'am. You can't only because, that's a good question. You can't because the angle is not between the sides. Good observation. Okay. Yes. If you have two angles. That's a good question. Because, okay, that's a good question. You're asking me, if two sides are the same, why don't they automatically determine the third side, okay? Let's say my hands are the two sides of this triangle you're talking about, right? Wouldn't this, if you were to put a side right there, wouldn't that be the end of your triangle? Yeah. What about that? What about that? Are these all the same triangles? No. They're all different. See, this is a different triangle than this one, then this one, then this one. But my hands are still the same length. Two sides don't determine the third side. It could be any length but the angle. Because the angles always have to add the same thing, you can. The sides can do anything they want. I'm going to take it. Yeah. I didn't.
It was impossible.
Well, what do you mean set you up to fail? You burst out of your seat. You set yourself up to fail. Not saying I don't like it when people volunteer for questions.